Before we go any further into this video, I would like to sincerely apologize because I was watching the clips and I noticed that at the beginning I forget to mention match flames. So when I first mention flames, just know that I'm referring to match flames, like the flames coming off matches. Later on I will be referring to traditional flames, but I will be specific with that one and I will mention traditional flames. So thank you. Hi guys! So today I will be explaining a phenomenon that may be familiar to some or new to others. Or if you're like me, you never even noticed it until you saw photos of it. Right now I currently don't have any matches, so this is just going to be good enough. It's going to be the same results. So as I turn on the light, you see the shadow of the lighter itself, but you don't see the shadow of the flame. See? So shadows occur when light is being blocked or redirected. Therefore, a flame can't really have a shadow since nothing's really blocking light from entering it. Let's also not forget to mention the fact that the flame itself is a light. So for a light to hit another light and for there to be a shadow, that just don't make sense.
What do I know? You know, Mr. Burns, you're the genius here.
So as I'm doing my research for this project, I come across this one candle that was lit. It's lit. Its flame had a shadow. And I was like, well, if I'm gonna do this project, I can't be having the internet turn against me because, you know, that's not right. So as I searched it up, there was an explanation to it. The hot flame can be seen just because of the lower density that it has compared to the air around it. So due to the lower density of the flame, the light has a lower refractive index, which means that the light can slowly bend away. The slight shadow that is happening is not necessarily due to the absorption of the light, but it's due to the refraction of light. So you're probably sitting here like,
what's the difference between the refraction of light and the absorption of light?
Let me explain.
right here, right now, I'm showing you the absorption of light. If my hand weren't absorbing the light that's hitting it, then you would not be able to see this shadow that you see. Or my little bunny, bunny hopping. Okay. So now that I've showed you guys an example of the absorption of light, I'm going to show you an example of the refraction of light. This is a glass of water that I have. The spoon that I put in it is not bent, it is not broken, and it is not crooked. The spoon is perfectly formed. It is okay. Okay? But when I place it in water, it bends in a certain way, or it looks like it is broken or bent or whatever. This happens because of the refraction of light. So it can be possible for traditional fires to have shadows. A traditional fire is a hydrogen carbon flame, which is mixed with a number of components. The basic ones being hydrocarbon fuel molecules and oxygen molecules. So the reason why this shadow is occurring, again, is because of the refraction of light. The hot flame that is being produced mixes with the cool air around it, which alters the direction of the light that's going through it. It shifts it in a different way, which is what we see here. Shifts it in a different way. Let's not forget to mention that another contribution to a shadow that is being seen because of a flame is because of the soot that is coming off of the flame, which absorbs the light, which plays a role in the shadow.
Did you understand that?
So to summarize everything in this video, a flame coming off of a match will not have a shadow unless the carbon soot that is present is heavy enough or thick enough to block or redirect the light that is passing through it. That's one. Or two, the flame's density is lower than the density around it, which will redirect the light that is passing through it. So I hope that the next time you light up a match, you're one, safe, and two, you think of everything that I just said in this video, as well as I hope that match does not have a shadow, because if it does, then I failed this project.
Give this video a thumbs up, like, and subscribe to my channel.
Bye! Bonus edition! So, as I was looking at the little clips that I was making, I was like, hey, there's a lot of soccer balls in this video. So I just wanted to see if any of you guys were counting. So be sure to comment down below. Just kidding. Just raise your hand at the end of watching this video if we do watch the videos in class. And just let me know, how many soccer balls did you see in this video? Sorry, Mr. Burns, for the quick sidetrack. Nothing science related. Just saying, okay, now I'm for real out this time.